Hey, hello everyone. Welcome to our channel Physics, where we actually learn physics. So in this lecture, we will be solving this problem. This is 2.16, okay, from chapter 2, units and measurements. Okay, this is 11th standard, okay, CBSE. Okay, so let's solve this problem. It's a very simple problem. Okay, the problem says that the unit of length convenient on the atomic scale is known as an angstrom. Okay, so what they are saying is angstrom is one of the units that we use, okay, very often at the atomic scales, okay, and is denoted by a dot or a naught, something like this. This is how we represent angstrom. Okay, and 1 angstrom unit is equal to 10 raised to minus 10 meters. Okay, so this is given here, you can see. Okay, now the size of the hydrogen atom is about 0.5 angstrom units. Okay, the size of the hydrogen atom is how much? 0.5 angstrom units. What is the total atomic volume in meter cube of a mole of hydrogen atoms? Okay, so that is what we have to find out. So first of all, you can see few conditions, few equations are given, like the radius of the hydrogen atom approximately is given 0.5 angstrom unit. Okay, but we know 1 angstrom unit is how much? 10 raised to minus 10. That's why R is equal to 0.5 into 10 raised to minus 10 meters. Okay, so that is the radius of the hydrogen atom for us. Now we have to find out the volume in meter cube. But volume of what? Volume of 1 mole of hydrogen atoms. Okay, 1 mole. What is mole, by the way? Mole is the unit. Okay, unit for the measurement of what? Unit for the measurement of amount of substance. Okay, of amount of substance. Mole is what? Mole is the unit for the measurement of amount of substance. Okay, so over here, for 1 mole of hydrogen atom, what is the volume? We have to find out. Now what do we mean by 1 mole? 1 mole is actually equal to nothing but the Avogadro's number. Okay, N naught, it is equal to 6.023 into 10 raised to 23 atoms. Okay, 1 mole of any substance, okay, 1 mole of any substance contain these many number of atoms. Okay, that is how we measure it. That is how we measure any substance. Okay, so these are the few conditions that are given, so we will use these conditions. Okay, and we will solve for the volume. Okay, first of all, what we will do is we will find out the volume for 1. Okay, or let's say V dash. Let's say V dash is the volume. Okay, for example, volume of 1 hydrogen atom. Let's say, okay, let's say V dash is the volume of 1 hydrogen atom. Okay, so how do we calculate the volume? There is a simple formula, right? 4 by 3 pi r cube. This is nothing but the volume of a sphere, because atom is roughly a sphere, spherical body. So that's why we can say volume of this atom is 4 by 3 pi r cube. So for a single atom, we can write 4 by 3 into 3.14 into, what is r? Look at this. R is this. We can write this as 5 into 10 raised to minus 11 meters, right? So we can write this as 5 into 10 raised to minus 11 cube, right? Okay, yes, so you got this. Okay, so let's solve this now. Okay, let's solve this and let's calculate what V dash can be. Okay, so V dash over here is 4 by 3 into 3.14 into, see here, there is a 5 cube. So 5 cube into 10 raised to minus 11 cube. Okay, then we can write here V dash is equal to 4 by 3 into 3.14 into 5 cube. What is 5 cube? It's 125, right? Okay, into 10 raised to minus 11 raised to 3 will be 10 raised to minus 33. Okay, minus 30. You just get multiplied. Okay, now we have everything that we want. Let's multiply all these numbers and let's see what we get. So here is a calculator. Okay, so what we can do is see 4. You can see 4 into 3.14, okay, into 125, okay, 125 equal to this, all divided by 3, right? There is a 3 in this denominator also, equal to, yes, here it is. Okay, so the answer is 523.333. okay, so let's write this. V dash is equal to 523.33 into 10 raised to minus 33, or we can write this as 5.23. okay, let's just not take these, okay, 31, okay, because we have shifted the decimal point. Okay, see, we have just rounded them off, we have just cancelled them off. Why? Because we don't need them right now, because anyways, if you observe this carefully, here our radius, the radius of this, it has got only one significant figure, right? So we don't need that many number of significant figures in the answer. Okay, so right now we will keep it like this. Okay, in the final answer we will only have one significant figure. Right now let's keep it, final answer will be rounded off to only one significant figure. Okay, now this is the volume for one hydrogen atom, right? This is the volume of one hydrogen atom. Now what we want is volume for the whole 1 mole of hydrogen atom.